Welcome to part 4 of the EIQ Tools demo. In these final few videos, we will focus on the actual configuration of an EIQ superadapter. The first step is creating an EIQ index for the data source. In the previous video, we took a look at the database and created the connection. Now we will build the index on it using the EIQ Server RTI Tool. Launch the RTI tool and create a brand new map. Maps capture all the activities that we do in a session. Select the police data source and enter the authentication credentials. Then, specify the index path and enter a name for the index. You can also select to load any views or synonyms, but ignore those for now. This next window is a default map of the data source data types against EIQ index data types. We can leave these as their defaults for now. The RTI tool loads in profile mode by default. That means indexes built in this mode will be profile indexes rather than the full-fledged EIQ indexes. Profile indexes do not have some of the information and some of the structures that the complete indexes contain. They are lightweight indexes that are used for profiling, understanding the data, and creating and developing transforms. When the schema loads, on the left side is the information for the data source we connected to. The various schemas available in the data source appear as the main node. Expanding the schema will reveal the tables and columns within. The right side displays what's going on in the EIQ index. As you may notice, there's nothing there until we select and add the tables and columns that we're interested in building the index with. We won't have anything on the right side yet. In this demo, we're going to select the low person, incident, and person incident association tables. I'll save the map so I can reuse or edit it if I need to. With the tables and columns selected, we can go ahead and build the profile indexes. As you can see, there are several thousands of records in each of the tables. The index building should be done in a couple seconds. Now we can look at the data in the profile indexes by right-clicking a column and selecting Analyze Data. There's an overall analysis that will count unique values, distinct values, duplicates, minimum and maximum values, and nulls and blanks. The most frequent top 5 and bottom 5 values and the actual value distribution for each of the values can also be seen here. Let's take a look at one of the columns that we're interested in, the address state column. As we saw in an earlier video, we deliberately introduced dirty and non-standard data into the state column for demonstration purposes. We can apply transforms to correct this dirty data and fix the issue. The EIQ product suite provides a lookup transform that will correct this issue at the index level. The lookup transform allows us to use a file to look up the incoming values from the data source and substitute them with the value of our choice. This is the lookup file in an Excel sheet. This column contains the incoming value from the data source, and the second column contains the substitute that we want in the index. Once we apply the transform, we can preview it. As you can see, we no longer see the dirty non-standard data. In its place, we see the transform data. Users can add their own transforms or build transforms and add them using the Transform SDK. Transforms are applied when we build the full indexes. We will then see the appropriate state names and not the incorrect two-letter codes that we saw before. At this point, we can switch to RTI mode. Before we get into building the RTI indexes, I would like to highlight some of the important menu items. This is the global data type map where we can change the mapping of the source data types and the index data type map. We were first presented with this window during setup. Changes will apply to all the tables and columns. We can also apply and change various properties through the options menu. One of interest is entity extraction. Here we can actually extract entities out of a memo field or a text column by connecting to WhamTech's Java Gateway server. It uses a third-party text analytics platform to extract entities and provide them to the RTI tool. This lets us build EIQ indexes for more structured query processing against data coming from free-form text fields or documents. We can also set default key types. I'll go into some of the details about what virtual keys and non-virtual keys are and what they allow us to do. By default, all the columns are designated as virtual keys, meaning we do not keep the data in the EIQ indexes. We only build the trees and lists that enable us to do the searches, isolate the records of interest, and do most of the query processing. We go to the data source to actually assemble the final results. Virtual keys enable us to execute queries without having to keep data in the indexes themselves. We also have options to keep data. If we use a non-virtual key, indexes will still contain the data. There's also a non-key flag that we can set. This means that data is kept, but is not part of the index build. There may be cases where that can be useful. A virtual column means the indexes are aware of the column, but they do not have the keys or the trees to enable query processing on that particular column. However, it can always be retrieved from the data source in the results. Ultimately, there are multiple ways to build indexes. You can choose to keep the data, not keep the data, or understand there are columns but have neither the keys nor the data for them. This presents you with many options. When we build the RTI indexes, each table needs to have what we call a row ID column. This column is like a primary key column in which the EIQ server goes to the data source to retrieve the final results. I'm going to designate a row ID column for each of the tables. For the person incident association table, no single column can be designated as a row ID column, so both columns can be designated as row ID in combination. One will be primary and the other secondary. We can also designate foreign key information. This tells the EIQ server to perform some of the joins automatically. So designate the person ID column in the person incident table as a foreign key coming from person, and designate the incident ID column as the foreign key coming from incident. We're also going to build some additional text search indexes on some of the large text columns. We'll select some of the options for building additional indexes. For example, stem indexes on the stem of the words, the synonyms of the words, sounds of the words, and so on. I can also use this window to enable a proximity search. It's a good idea to save the map again. With that, we can go ahead and build the indexes. It should take a minute or so to build the indexes, especially because of the text search indexes. That's where most of the time will be spent building indexes. We have now completed the first step of configuring an EIQ superadapter. The next step involves configuring the EIQ superadapter virtual data source at the EIQ server.